Today we're looking at simplifying radicals. We're going to review properties of radicals that we learned in Math 8. The first thing we're going to talk about is a square root. A number r is a square root of a number a if r squared equals a. A positive number a has two square roots, written as the square root of a and negative square root of a. The positive square root of a number is also called the principal square root. The expression square root of a is called a radical. So let's look at properties of square roots. We have the product property. The square root of a times b is equal to the square root of a times the square root of b. And the quotient property is the square root of a divided by b equals the square root of a divided by the square root of b. A radical is simplified if all perfect square factors of the radicand have been moved out of the radical. So let's look at simplifying these. We're going to look at 1 through 3. These can also, depending on your calculator, a lot of calculators will have where it will simplify the square root for you. But let's just see what the calculator is doing. First thing you're going to do is you're going to think of any two numbers that equal 18. You could either use 2 and 9 or 6 and 3. Let's start with 2 and 9. Now 2 is a prime number. It does not break down anymore, so 2 is our lowest number, but 9 will break down into a 3 and a 3. You want to break these down to prime numbers. So since this is 2 times 3 times 3, every square root we're looking for groups of 2's that we can pull out to the front. So this would be equal to 3 times the square root of 2. Now let's look at number 28. Think of any two numbers that equal 28 when you multiply them. I'm going to do 7 times 4. Now 7 is a prime number. It doesn't break down anymore, but 4 is not. It breaks down to 2 and 2. Now remember, with a square root, we're looking for groups of 2's. I have two 2's here. You take the 2's out to the front, and you leave whatever is left over underneath that square root. Now 120, we've got 2 and 60, 2 and 30, 5 and 6, and 2 and 5 are all prime, but 6 breaks down to 2 and 3. We're going to look for groups of 2 that we can pull out front. The only group of 2 that we have is a 2. So we're going to pull the 2 out front, and then we want to write all the numbers that are left over. They're going to go back underneath the square root. 5 times 2 is 10. 10 times 3 is 30. So this would be equal to 2 square root of 30. Now 300, if I say 3 times 100, 3 is prime. 100 is 10 and 10. Now 10 breaks down further to 2 and 5, but once we find a pair of numbers, we can just stop there. Because then it'll just save us from having to times it out. So the 10 comes out front, the leftover is a 3. So we have 10 square root of 3. Number 5, 20, we're going to break it down, 5 and 4. 5 is prime, but 4 is not. It breaks down to 2 and 2. The 2's come out front with this 3. There's already a 3, so we're going to multiply the 2 and the 3 together to get a 6. And then we still have a square root of 5 underneath the radical. Let's go to number 6, where 18 is 6 times 3. We did it earlier with 9 and 2. 6 breaks down to 2 and 3. That 3, we can bring it out front along with the 7. 7 times 3 is 21, and then we still have that 2 left over under the square root. When a radical is in the denominator of a fraction, you can multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing the denominator. What that does is it gets all of the radicals out of the denominator. It allows everyone to have the same answer. Now on number 8, I have 1 divided by the square root of 2. I don't want to have a radical in the denominator, so what I'm going to do is I'm going to times it by a 1 in the form of square root of 2 divided by square root of 2. Now anything divided by itself is just a 1. So if we take 1 times this 1 divided by the square root of 2 times 1, it gives us itself. But it's going to look a little bit different. So 1 times the square root of 2 is the square root of 2. Square root of 2 times square root of 2 is square root of 4, which just equals a 2. So our answer here is square root of 2 divided by 2. And you can put this into your calculator. A lot of calculators will do this for you, depending on the calculator. But this is how the calculator gets that. Number 9, we have 4 divided by the square root of 5. We're going to multiply the top and bottom, the numerator and the denominator, by the square root of 5. And this is just timesing this fraction by a 1. 1 times anything is itself. So we have not changed the fraction. We're just going to rearrange it a little bit. So the square root is going to change to the top. 4 times square root of 5. Square root of 5 times square root of 5 is square root of 25, which just equals a 5. And you can just, if you have 2 square roots that are multiplying together, these are the numbers that are pairs, and they're just going to come out to the front. And there's just going to be a 1 left over, so we don't need the square root anymore. Square root of 25, which is just 5. So this would be our answer for number 9. Number 10, we have 2 divided by the square root of 3. We're going to times it by a 1, but we want to get rid of the square root of 3 in the denominator, so we're going to times by the square root of 3 divided by the square root of 3. This is going to equal 2 square root of 3 all over 3. So square root of 3 times square root of 3 is square root of 9, which just ends up being the 3. Number 11, we have a square root of 3 in the denominator. We want to rationalize the denominator, which means move the denominator to the top. So we're going to times both the top and the bottom by the square root of 3. Okay, this is going to equal 3 square root of 3 divided by 3. Now notice when I do this, I have a 3 in the numerator and a 3 in the denominator. Those 3's are going to cancel out to just equal the square root of 3. Now number 12, this is equal to the square root of 16 divided by the square root of 5. This is square root of 16 is 4 divided by the square root of 5. We want to get that square root off of the denominator. We're going to times this top by square root of 5 and the bottom by the square root of 5. This on the numerator, when we multiply 4 square root of 5, we just have 4 square root of 5. And square root of 5 times square root of 5 is square root of 25, which is just a 5. 13, we have square root of 7 over 5. This equals the square root of 7 divided by the square root of 5. Now we don't want the square root in the denominator, so what we're going to do is we're going to times both top and bottom by the same thing, which is square root of 5, and what that's going to do is going to allow us to get that square root off of the denominator. Square root of 7 times square root of 5 is square root of 35. This doesn't break down because 35 is just 7 times 5. Those are both prime numbers. There are no numbers that can be pulled out of that square root, so it's just going to be square root of 35. Square root of 5 times square root of 5 is square root of 25, which just equals a 5. So our answer on number 13 will be the square root of 35 divided by 5.